So I'm here with a challenge. I need to do a 45 minutes presentation in 20 minutes in English. So buckle up, get ready. It's not going to be easy. It's going to go fast. So you probably know about me. I'm mostly famous for my work at Mozilla, but I do tons of other things. I'm especially into podcasts these days and still run my blog, standblog.org. I would like to talk to you about Moore's Law, named from Gordon Moore, which basically it was, I'm sure you all know Moore's Law, but it really started in 1971 with the first Intel microprocessor, the Intel 4004. Which is an amazing piece of hardware and a complete lame, I would say, completely lame, because it is, when you compare it to a modern processor, it really is just a shame. But it was the beginning of a revolution. As you can see, a modern processor has a clock which is 5,000 faster. The words are 16 times larger, and you casually have 10 cores instead of just one. So this is really a lame duck, but it was the first of an amazing series. Moore's Law, and it comes from Gordon Moore's name. Gordon Moore died last year. I think he was fortune number 96 in the world, so he was a really rich man, because Moore's Law made him really rich, because he co-founded Intel, and he discovered that by investing in research and development, they would be able to pack twice as many transistors on a semiconductor as 2 years earlier. And if they keep investing in R&D and building the factories for semiconductors, they would be able to keep this pace of doubling the number of transistors every 2 years. And indeed, it worked, because you can see the Intel 4004 on the bottom left, which is 2,300 transistors on it. And if you go on the top right, you're roughly at 15 billion transistors. You see the scale is exponential on the left. And all of this has happened in 50 years. So Gordon Moore's law is the number of transistors in an integrated circuit doubles every 24 months. But there was another law that came with it, and we're a little less proud of it, which is it was given by Octet Vert, which was a German computer scientist, a very bright man, who said software is becoming slower, faster than hardware is becoming faster. Yeah, I give you a couple of seconds, but yes, and unfortunately, Octet was right. And we can say this with simpler words. Basically, what Intel gives you, Microsoft takes it back. and unfortunately, it is completely true. And I mean, all of us, I suspect, in this room are computer scientists, and it's a bit of a shame, because thanks to Gordon Moore's law, we had a lot of resources, and we've been wasting these resources by building slower and slower software. And I have several examples. Like, for example, did you know that a Lenovo X1 Carbon with the latest processor running Windows is 5 times slower than an Apple II to display a character? A machine from the 90s, in the 80s, is actually 5 times faster than a recent machine running Windows, just to display one character on the screen. And it's embarrassing. Frankly, it's embarrassing. The size of web pages, on average, is 150 times bigger now than 25 years ago. Office and Windows need 171 more RAM to run from 20 years ago. Are your Word documents, Excel spreadsheets, 171 times better, they're probably better, but not that much, right? It's just an example of the waste we have been doing as an industry, doing software, writing software, which is crappy compared to all the resources. So we're wasting the hardware resources that we've been given by Moore's law. Why is that? Well, basically, it happens that a computer programmer times is worth a lot of money. It's expensive. So you have two choices. Either you ask the guy to write a feature in your product, and when he's done, yeah, maybe the feature is well written and optimized and everything. Maybe not. You don't know. You don't know until you've tried to rewrite it in a better way. But actually, it's in most cases would decide to use the person's time to build another new feature. Why is that? Because if you rewrite the feature to make it more optimized, maybe it's better, maybe it's faster, maybe you are going to approach the problem in a better solution. But then in 2 years from now, with Moore's law, you don't care anymore because you have twice the power, twice the computing power. So the optimization you have been doing 2 years ago doesn't really matter. You don't see it anymore because you have faster computers. So in fact, it makes more sense to ask the programmer to go and build a new feature so that your product becomes more desirable. And so what you end up is a product which is not optimized, that's one. And second, the product has one more feature, so it's more heavy, more bloated, and therefore it's slower. And in most cases, this is exactly what happens. Every time we have to choose between optimizing or creating a new feature, we go and build a new feature, and we end up with a slow product. And this leads to us, each of us, or people around us saying, wow, my computer is too slow, I need to change it. Well, big news, people, computers and smartphones and servers don't get slower over time. They do not. It's just that they have a certain capacity, certain computing capacity, and we put new software on it, which is bigger, less optimized, with more features, and therefore they seem to be slower. There are tiny exceptions, like the iPhone at some point got slower because of battery issues, but this is really the exception. So we are putting our smartphones and servers and PCs to the dump. We say it's recycle. You know, recycle in IT is bullshit. It's almost never recycled, right? Because it's very complicated. You can't take a chip and remove the gold from it, remove the copper from it, all of that. It's too complicated. You don't do it. You just throw it in nature. And this is why we change our smartphone every 3 years, and that's bad. And what if we could end Moore's law? It's kind of scary because, you know, all of us in this room are too young to know the world before Moore's law. I'm 57, and when I started computing, I was 14 in 1980, and Moore's law was around for already 9 years before me. So everyone who's doing IT these days has been born in the industry with Moore's law as a fact. Nobody knows the world without Moore's law. It's like the water for fishes. You're so used to Moore's law, you don't even think it can't be around. It's like if you could tell to a fish, we're going to remove the water around you, right? It should be really scary, but it would be nice if it could happen. Here's a famous quote by Upton Sinclair, which I like really much. It's difficult to get a man to understand something when his salary depends on his not understanding it. This is the case for all of us, right? We make money thanks to Moore's law. And you know what? We need to end Moore's law. Why is that? Well, you need to know that basically the impact, the environmental impact of digital happens when you are in the building phase, when you are building, manufacturing the hardware. Running the software is roughly 20–25% on the impact. It uses water, mineral resources, it emits greenhouse gases, uses energy. And the first three examples, it's manufacturing the hardware that uses the resources, not running the software. And I'm sure you've heard about climate change. If not, then you should read stuff. Because it's happening and it's going to change your life. So a couple of, and it's happening everywhere and in different ways. Basically, climate change is weather events, extreme weather events happening more often and bigger events, more dangerous events. And it's going to get worse, as you will see. This is three things on one slide. The first one is conferences where we decided that we need to do something and change everything with regards to climate change. The second is the CO2 concentration in the air, which keep getting worse and worse. So then you can wonder whether all conferences are really making an impact or not. And the third one is temperature evolution. Green, no green there. Blue is good, red is bad. As you can see, it's getting worse, right? So we know we need to do something about climate change, and nothing happens. And here are a few climate change scenarios from the IPCC, that's GIEC in French. And basically, we need to be roughly at the bottom, and we are on the orange funnel, roughly a bit under 3 degrees, which is terrible. Absolutely terrible. For everybody. It's even worse in France and in Europe. We're warming up faster than other countries. So the Paris Accord says we should be between 1.5 and 2 if we want to avoid terrible nightmares, but we are not heading there. Another problem we have, so it's not just greenhouse gases and CO2 and everything, it's also biodiversity collapse. It's already happening. This is the past, from 1970 to today. There is a major problem with biodiversity, which is collapsing. Why is this a problem? It's because basically biodiversity gives us services to clean the air, grow the food, clean the water, everything that we use as humans on the planet. And if biodiversity is in trouble, this means that the support systems we use for life is in trouble. Now, let's get back to IT and more enthusiast stuff, but I couldn't not talk about the problems that we face as humans. I'm going to talk about optimization. As Octet Vert said, we write terrible software and it gets worse and worse. Well, the good news is we can optimize software, and I'm going to give you 3 examples. The first one is from a friend of mine, Pierre Bessac, and Pierre wrote a Python script, but he thought it was too long, so he decided to optimize it a bit. And within a few, well, I think it took him like half an hour to optimize his work and make it 60 times faster. So it's not just, 20% better. No, it's 60 times faster. Which means, by the way, that he was wasting 60 times too much resources before that, right? So just by optimizing, he can make it 60 times faster. And as you can see, he's pretty proud of it, like, I did it, right? It's something I've noticed with people who optimize, they're proud. Look at, next one. He's proud too. This is my colleague, Aurélien, who's doing machine learning. And Aurélien had a batch work that took 15 hours, which is down now to 10 seconds because he optimized his learning phase for this machine learning algorithm. So it's 5,400 times faster. It's doable. It takes brain, it takes time, it takes energy, dedication, focus, but he made it happen. And so this meant that he wasted 5,000 times too much resources in the past. And now the third example that I really like, he's proud too, but not that much, because he wrote a Python script that took 32 days. And he made a video out of it. I recommend you watching it. It's in English. You will love it. It's super funny. And basically, someone offered to optimize his work. The first version took 15 minutes to run, and the latest version took 6.7 milliseconds. That's 400 million times faster. The guy is called Matt Parker. Remember his name because we'll talk about him later. And so I invented Irum's law, which is basically Moore's law, but in reverse. So poor Gordon has his head upside down. Sorry for that, Gordon. And like Gordon decided he would optimize hardware to make it work twice as fast every 2 years, we can decide to optimize software by a factor of 2 every 2 years. 2, factor of 2. It's nothing compared to 5,000 or 60 times or 400 million times. 2 is easy. If we manage to do that, well, we free resources, computing resources, that we already have. And so it means we can use the remaining resources to build new products, new stuff, create new stuff. You know, this is what we like about IT. We create new stuff. We can use this thing, and so we avoid having to manufacture new hardware. And if we don't manufacture new hardware, means we save 80% or 75% of the impact we have on the world. So the good news is Moore's law is already dead. Look at that. Actually, in 2015, it stopped improving. I'm still using machines from 2011 as of today on a regular basis. Right? Because processors, x86 processors from Intel and AMD, they just stopped improving. They're done. Which is a problem for, of course, Intel and AMD. They say the Moore's law is not so dead. It's already moving. I call it a dead cat bounce. I don't know if you're familiar with the concept. Why is that? It's because a single transistor price has been steady since 2011. It's very important that the transistor price goes down at every generation, because as we pack more transistors in a semiconductor, we need to make sure each of them is less expensive, but it's not happening anymore. This is why processor prices are increasing, but not speed. And so what do we do now? Well, basically, we keep making our developers better at doing their job. So this is the code performance, and this is the easy to maintain. Is it easy to maintain the code? Well, first, beginners, they write terrible code, which is not performing well and not easy to maintain or read. That's okay. I've been a beginner too, and I think my code was worse than everybody else's. But by doing software craftsmanship and encouraging people to become better at their job, we can make them senior developers. Means performance is better, code is faster, it's easier to maintain. It's more readable. And we already do that. We need to keep doing that. So keep doing what you did until now. Except now we do further, and we increase code performance by focusing on what really needs to be critically improved. You know, there are terrible pieces of code, you know, places where Matt Parker has left traces in your information system. We need to find where they are, and we need to focus on improving them. Because it's like a Pareto thing, 80-20, you know. Yeah, you have a few pieces that are really terribly written, and we need to optimize, and the rest is okay. Now, be careful, because the more you optimize, if you optimize too far, then you get into trouble, because it won't be easy to maintain this piece of software, because it may become more complex. So you need to find the right place where to put the cursor and make sure what to do. And if we do that, then we achieve Moore's law. We optimize software by a factor of 2 every 2 years, means 3 things. First, digital will remain in planetary limits. We will stop screwing the planet with, you know, manufacturing digital goods. Because we don't need to build new hardware, because we optimize the software. Second, we will be proud of the work we do. Finally, we stop making crap. We make good products. And third, we keep innovating, which is basically, I'm sure, the reason why all of us came to IT in the first place. I'm sorry I don't have time for questions, because I'm already past the 20 minutes. Thank you very much.